in this area for Verizon. He tells me most of the time he's been spending on the East Coast because that's where all the customers are, and there's just way more demand than there's time in a day. So Ashok comes to Verizon from after a very distinguished career at NASA, where he led the machine learning and intelligent data analysis teams. And he's done some very spectacular work, probably most well known for what's called integrated vehicle management systems. So, here when you think about the edge of the network, the edge is somewhere on Earth. But their network, the edge is in deep space. In fact, recently Voyager officially went out of the solar system, so it's kind of beyond deep space. And he's used data mining, text mining, anomaly detection type techniques there. So without further ado, Ashok.
Thanks very much for that kind introduction, Jaideep. My name is Ashok Srivastava, and I'm going to be talking to you today about a topic that I find particularly fascinating, and that is how to interact with customers in real time if you have big data. Now, to give you a context of when I'm talking about big data in the context of Verizon, we are generating on the order of 5 to 8 petabytes of data per day. And that is kind of half the story. That's the data that's actually transmitted over one of the networks. The data about the data, in other words, the metadata, is also on the order of about 5 to 8 petabytes of data. So the landscape I'd like to draw for you is as follows, that on one side you have 5 to 8 petabytes of data. On the other side you have a customer. And in real time, that means in the real time of the customer, not the real time of the analyst, but in the real time of the customer, you want to do an interaction that is useful and valuable. Now, some of you might think that that's kind of a coded way of talking about advertising. And in fact, advertising is done that way. But there are many other things that can be done in the same context that are not advertising-based. And I think this is what's very exciting about this situation, is that we have tremendous amount of data, but we also have a large customer base, and we have the opportunity now to create new product lines that can help the customers in a variety of ways. So let me give you a bit of a background about the way we're thinking about this. So stepping back from big data and petabytes and all of these things, let's just look at what's happening in the world right now in terms of the economic models and the economic situation. So by 2020, these countries, Brazil, China, Russia, India, and South Africa, are expected to account for about half of all GDP growth in the world. This is a tremendous change. I don't need to tell this audience that. Currently, if you look at the rankings of different countries, the US is at the top at about $14 trillion, I should say, in the economy. But by 2050, it's going to change. And for a large company like Verizon, this has some significant implications. The implications are that we can't continue to do business as usual. And I would argue that most companies can't continue to do business as usual, particularly if they're in the technology sector, because the landscape is changing. It's not going to be the same in the future as it was in the past. And it has tremendous opportunity associated with it. Now, let's look at this. If you see on the y-axis, I've plotted the percent planning to adopt cloud services in this case. And you'll see that based on the averages, Japan, US, Canada, UK, the major global powerhouses of today are actually in the negative territory. And where's the positive growth? It's actually on the right-hand side with Mexico, Brazil, China, India leading the way, right? This is a tremendous change in the way technology is being thought of. And look at the technologies we're talking about. For example, SaaS, software as a service, infrastructure as a service, platforms as a service. These sorts of things we're seeing more and more coming up in other parts of the world. Not to say that in the United States, not to say that in the current major economies it's not going to be used, but the adoption rate is going to be different. And that poses a tremendous opportunity. Particularly for those of us working in big data and analytics, it poses a tremendous opportunity because we have the opportunity to create new ecosystems, new platforms that can be used by many, many different kinds of companies all over the world. Not only companies that are doing B2B activities, but also B2C and even B2B2C, in other words, business to consumer interactions. All of that can be modeled and dealt with in this way. So from the context of this high-level view of what's going on in the economy, what we're seeing is a pretty catalytic combination of cloud computing and mobility leading to what we're calling the liberation of information. So no longer is the computing paradigm centralized, as we've all heard many times. No longer is it really about big mainframe machines with proprietary hardware. It's really about the fact that you're carrying powerful machines in your pocket, right? And there's information associated with that that can be used to make the world a better place. And that's the direction that we're thinking about. So in the context, my context of coming to Verizon about 7 months ago from NASA, one of the things that was really interesting to me is the opportunity to take large-scale machine learning, many petabytes of data being generated per day, a vast network, and putting all of these three things together in order not only to liberate information, but to use it in order to increase societal benefit. And that's, I think, a tremendous opportunity that this company has, but also many, many other companies have at their disposal in the future. So it's really a move from point solutions that solve singular problems, such as problems about specific aspects of the network or customer analytics, trying to improve something about customer retention, things like that. It's really about moving from there to a world of platforms and ecosystems where companies, not just large companies like Verizon, but small companies can create their own ecosystems, and those ecosystems can power the next generation of technologies, right? And so if you see the way we've shown it here, big data is kind of in the middle of this, right? It's not the end goal. It's kind of a stepping stone towards converged solutions, towards platforms and ecosystems, which are really driving highly personalized service across a variety of touch points. Right? That's the direction that I think a lot of us are headed. And the question is, how does big data and analytics interact in this kind of a situation? So it's amazing to me. This graph is completely amazing to me. Now, what it's telling us is that 1 in 3 business leaders frequently make critical decisions without the information they need. And in light of the talk we just heard before, which was talking a lot about the need for analytics and the use of analytics, this is a remarkable statistic. 1 in 3 don't have the information. Now, that's interesting, and we can discuss that and discuss the implications about it. But consider this, that really when I'm talking about big data and analytics and real-time computing platforms, this is kind of irrelevant. Because there, the consumer is not a human being reading a report with a bunch of pie charts and bars on it, right? There, the end consumer is another machine that's taking action on the data that's coming in. That's the future that we're thinking about. No longer is it about the data being housed in some huge system and then humans kind of going through that data, analyzing it, making a decision. We think that would be important. And of course, that would hopefully bump the statistics up from instead of 1 in 3 to maybe 1.5 in 3 or something like that, right? That would be a very important goal. But a bigger goal, a more complex goal, is to say that all of that data, that 5 to 8 petabytes, is going into a system that's making decisions automatically within a few milliseconds about what should happen on the network or with respect to consumers. That's a different kind of goal, but it's still interesting to see statistics like this. So I won't go through the definition of big data. We already heard a great talk about it. I see these kinds of statistics, 100 terabytes. That's not really large data in the context of what we're talking about here. When a company a single company is generating that many petabytes per data. But that's one of the aspects. You need to have a lot of data. You need to have it coming in quickly. You need to have variety, and you need to have some variability in the data. And then you fall into the space of big data, according to some at least. Now, the question is, though, let's say that you have this kind of a system, and you're a big company. Or on the other hand, let's say you're a startup, and you aspire to have this kind of data. What can you do with it in order to improve the situation for your customers? So look at the time to decision and how it's decreasing. It's just amazing to me. I mean, on this side of the spectrum, we have days and weeks, and this is kind of the world of business intelligence and traditional analytics, financial forecasting, inventory reporting, retail pricing. All of these things can be done kind of on this order of time. But look at what's happening on this order of time. 10 milliseconds. Online ad placement, for instance. Or in my NASA days, you have about 2 seconds in order to determine whether or not to abort a launch. Okay? And what an aborting a launch means is that as the rocket is going up with astronauts on top, if you detect a problem, you have about 2 seconds in order to, number one, determine if this problem is catastrophic. Number two, eject the spacecraft so that it goes this way, and the rocket goes this way so that, number three, when the rocket is detonated, it doesn't injure the astronauts. That's a real-time system. And in that context, how does big data come into play? I'll give you another example from NASA that we worked on. Let's say that you have data coming from an aircraft during flight, and you have all of the data about its flight for all past times, and about the entire fleet, let's say. This is a real-life situation, and you want to determine at this moment in time whether or not there's going to be a problem on the aircraft, and if so, how big is it, and if it's going to be big, what should you do, right? In that kind of a context, real-time means something extremely strong, extremely potent. No longer is it about people reading reports about safety incidents that could occur on that aircraft. This is about what's happening here and now, and you have all of that data to go through. So in conjunction with Honeywell, we developed systems that are actually going to be deployed on the 777, Boeing 777, 787, and other aircraft that's going to do what I described. Take data from the aircraft in real time, analyze it, and make those kinds of decisions. And so this is another aspect of the way we think. And you'll know that from my aerospace background, it's kind of influencing the way we're thinking about what's going on in this field. So the data diversity is growing. I don't, again, need to go through this in detail, but the advent of mobile sensor data and social media is also changing the landscape. And I'll talk more about this in a moment. While it's true that there's tremendous data coming in, one thing that's really interesting is that the value of any bit of data is relatively small. What I mean by that is, let's go back a couple of hundred years to the time of Kepler. And you'll remember from your physics courses that Kepler had some data points that were coming in, and he started to figure out the orbits of the planets based on that data, right? It was a tremendous discovery. It changed the way we know physics and the way we appreciate the way the planets move around in the solar system. But how much data did he have? Very little. He was down at this end of the spectrum. Very little data, but tremendous insight garnered from that data. And why? It's because of physical models. It's because he built physical models, now known as Kepler's laws, that describe perfectly how that data can be explained and how the motion of the planets occur. Very little data, tremendous insight because of physics. On the other hand of the spectrum, look at what's going on now. We've got tremendous amounts of data coming in, petabytes or zettabytes, however you want to look at it. But each transaction or each bit of data, each Facebook bit, is really irrelevant, right? But it's the aggregate that starts to become important. And why? Because we don't have the physical models. And we're probably not going to get physical models that describe it. And so what do? Well, we start to look at statistical descriptions of the data and how the data moves and changes over time. And when you do that, particularly, for example, on graphs, when you look at changes in graphs over time, then things start to become very interesting and very complex. Different kinds of mathematics, different kinds of physics need to be thought of in order to explain it. Extremely interesting, almost as interesting perhaps as what Kepler and Newton did so many hundreds of years ago. So, in the traditional world, they're kind of share everything systems. I'm not going to go through the laundry list here, but share everything systems. You've got big proprietary hardware, you've got proprietary software running on it. It's kind of crunching through the data and generating a report at the end, right? On the other hand, the new world is a little different. It's kind of a share-nothing system. And we've heard today about integrated systems which are using both of these kinds of technologies, which make a lot of sense. These have distributed data sources, offer things like cloud computing, semi-structured or unstructured data, distributed file systems, and so forth. So this is another shift that's occurring. Now, I'll give you a little bit of background on the way we're thinking about analytics at Verizon and the way I've thought about it in the past. Really, it's about discovery, as opposed to counting. So when you count something, how many phones did we sell last week? That's an important question. You can use it to drive your business. We would hope that more than 1 in 3 executives use that kind of information in order to make their decisions. But really, it's counting at the end of the day in different ways. What analytics is about, and the way we're thinking of it, is quite different. It's about discovering something new from the data that you've observed. And remember, there's a tremendous amount of data that's being observed, and it's of different types of varieties. And so to do that becomes a bit more challenging. Now, it's really an art. And as I was preparing this slide, I was thinking about this phrase came to mind, the art of the possible, and I looked it up, and it was none other than Otto von Bismarck in the late 1800s who said, politics is the art of the possible. And after the last few days, we can really see that even back then there was some truth to what he was saying, right? But now let's take a look at it in the context of big data. So you can make a huge investment in terms of new hardware and software and hire a lot of things. But if you're embarking in this direction, one of the things to keep in mind is that you need to have a couple of key ingredients. Number one, you need to have the right set of people who are skilled and have the sufficient number of people who are skilled in dealing with these kinds of things. They'll help you understand what's possible. Data. You need to have data at the right level of granularity. Now, when I said 5 petabytes being generated per day, I wouldn't want anybody to think that I have a plan currently, which is to say, let's take that 5 petabytes per day and store it. Why? Well, because the granularity of that data isn't probably necessary for the applications that we're thinking about. I emphasize probably. It might be in the future, but right now it's not. And so what do? You aggregate. As you aggregate, you lose some information because it can be a lossy compression. But on the other hand, what you gain is efficiency in terms of storage and throughput, right? And so you need to be able to think about those and be willing to take a chance. I've worked with many companies who are not willing to take that chance, who say, we will store every single bit of data for as long as our privacy policy allows us to do. And for some companies, that makes sense. For other companies which are dealing with these kinds of data volumes, at least in my opinion at the moment, it doesn't make sense. You need to have the right infrastructure. And that means that that infrastructure needs to be allowing you to test what's possible. If you lock yourself into proprietary systems which are closed, it reduces the chance that you're going to be able to think about new things, right? Because you're going to be bound by what the developers, whoever they are and however bright they are, you're going to be bound by that. You need to have the flexibility to create new kinds of infrastructures, and that's what we've seen happening over the last many years. So to make these kinds of transformations, again, you need to take different data sources, and I've included new kinds of data here, like weather data, image data, video data, sensor data, all of these things, and put it into these types of systems. So we heard a lot about data warehouses already. We know about Hadoop. These two things can interact, and all of this going into different customer-facing applications. So at a company like Verizon, which has a lot of analysts, they might just be interested in reports at the end of the day, which is fine. But where we want to go is something quite different, towards real-time systems, like navigation systems, for instance, that are taking all of this data and processing it in real time so that it's useful to the end consumer. And here again, it may not be milliseconds, but it's really on the order of seconds that we need to be able to do this transmission. And so this arrow is an important arrow. How do you go from here to there in a few seconds when we have that much data on the left-hand side of this picture? That's the question. That's one of the key problems that we're working on. More interestingly than that, even for those of us that work in machine learning, is to say, not only are we going to do that, but we're now going to apply large-scale machine learning algorithms to it in order to do some more advanced types of things. Because here at the end of the day, you might just show a picture. You might say, there's a Starbucks next door. And for many business cases, that could be sufficient. But what if there was actually the need to do distributed computing and optimization at the end node, where the end node is your phone? How do you do that? That's another problem that we're thinking about. A question came up earlier about making confidences in predictions. How do you do that in the context where you have this much data and you have that little time? So we're working on bootstrap methods that can take data, aggregate it, and then build multiple predictors in order to make those confidence bounds. Because I agree with you that that's a key issue in making these kinds of systems work. It's a key issue in making the kinds of systems work where there's feedback. And I'll talk a bit more about that in a moment. So when you think about this from the business standpoint, there are different revenue streams that can be due to analytics. And I'm going to draw a line here and say, if you think about reports, it's kind of important. And as it was pointed out before, it can generate some revenue for a company like a telecommunications provider or a bank or some of these large corporations. But really, as you move up the stream to discovery systems, like I was describing, where something new is discovered and perhaps told to an individual and said, did you know that these kinds of attributes are predictive of customers that are likely to be interested in your next product or service? That's kind of cool, and so marketing can use it and take some decision. But really, what we're seeing is that when you move into predictions where the predictions are done in real time, things are very different. And now you can, often these things are going to be built on large-scale machine learning. And the type of revenue that can be obtained is both SaaS but plus shared revenue. So it's a very interesting paradigm shift that's occurring. So to capitalize on this, I'd argue that, in the early days, people were using subject matter expertise and limited data, and maybe based on my statistics, I have to say that's today also, but let's just ignore that for the moment. 1990 to 2005, you say that, data warehousing came into play and everybody said, let's use some reports. And now what's happening is big data infrastructure deployments. And what we're seeing in the future is machine decision making based on encoded domain knowledge and real-time data. That's a very heavy statement. So machine decision making, no longer is there a human reading a report, but the machine is making the decisions based on perhaps a convex optimization that's occurring across a very, very large network. Based on encoded domain knowledge, how do you get the domain knowledge that we all know, kind of going back to Kepler, how do we get that kind of knowledge that we have about how people interact and how they move and what's possible and what's not into a system that's operating in real time? It's a very challenging problem, something that we're thinking about. And then how do you take a decision on all of that in real time given the data volumes that we've been discussing? So there are many success stories and best practices. By the way, these are not from Verizon because I just started there. These are from previous work that I've done. And you can see that there are different kinds of best practices that come up based on the kinds of applications that you're working on. So when I was doing some work in online advertising, I realized that it's really critical to actually build profiles of customers early on in the phase. This might sound very obvious, but it's surprising how many times it's actually not done. When you go and you say, okay, show me the profiles, well, there are all these tables, and we've got Hadoop running over here, and hang on, we'll get it all integrated. That was a year or two ago, but really what you'll find is that this kind of thing happens. So if you're from the startup world, you might want to think about it right away. that this is going to be one of the key and fundamental aspects of the data that you need to deal with, and you need to house that in a way that allows for large-scale machine learning. Recommendation systems. From the Netflix prize and many other kinds of things, we've seen that combining predictions of multiple methods can be used to gain even better predictions. That's not terribly new news. Those people like Joydeep that work in the field of ensembles have known that for a long time. What's kind of new, though, and a little interesting at least, is that you can use the same methods to generate confidence intervals on your predictions. And that's kind of neat. And so some of the work that I've done in the past has taken that concept and applied it to things like real-time estimation of fuel consumption on aircraft. So this is work that I did at NASA to say, at this moment in time, based on all the data that we've seen about the aircraft and all of the history of it and its fleet, can I determine whether or not it's burning too much fuel at this moment in time? And the way we did that is through ensemble models as well as building the confidence intervals that were asked about before. Driving additional sales from customer bases can be done as well through real-time systems. So let me conclude here and talk about this chart on the right-hand side. Those of you who are familiar with controls will look at that closely and say, hey, wait a second, this guy is putting up model reference adaptive control picture up here. And those of you that are not, don't worry about it. Okay? But what's the concept that I've been talking about here? Well, you need to have some kind of a data-driven customer model, right? And that model cannot be physics-based. It has to be based on the data that is observed. You need to have some kind of an adjustment mechanism. That could be the interaction that you have with your consumer in one way or another. You need to have some ability to observe the consumer behavior. And obviously, we've talked a lot about that in the last two talks, that's available. And then you also need to have some ability to make automated decisions. I used the word automated because this could be a combination of humans and machines. When you put all of these things together, it is possible to create an adaptive architecture for optimal decision-making, where optimal is in quotes. It's determined by the cost functions that you employ. But still, something like this is possible, and it gives you an idea of the types of things that we're thinking about. I appreciate your attention, and if there's time, I can take a question or two.
So, we could take a brief question or two.
Yes, sir.
Yeah. A question for you on big data analytics and time scales. This is just my view that in short time scales, big data analytics and predictions can be almost useless. But when time scales get longer, there's actually some meaning that we get.
Well, so the question was, in short time scales, is it the case that big data and analytics are useless, but on longer time scales, are they useful? So my response is that actually I think that even on short time scales, the predictions are useful from big data and analytics. Many examples of this. Finance, for instance. In contexts that I've worked in the past, you need to make decisions based on real-time ticker data, lots of data. So there, really, you need to make the decision quickly. And you need to make predictions quickly. Another context, real-time bidding systems that you would find in online and mobile advertising. There is a real-time component to it. You have about 30 milliseconds to figure out if you want to bid, how much you want to bid, choose the winner, deliver the ad, all of that pretty much in 30 seconds, compete amongst a number of players. So their prediction does need to happen on a very, very fast time scale. Any other questions? Okay, thank you very much.
So thanks to the ever-eloquent Ashok once again. And what we'll do is convene for a short break. Since we are a bit behind on time, we'll reconvene at 11 o'clock. So to your left, through those doors, there's some coffee. And to the right, in the room diagonally across, there's a poster session. So you could be at both or either, or just chat with your friends. So once again, we will be back at 11 o'clock. Thank you.